of us coordinate, okay, and try to give a we try to cover broad spectrum of computer science as much as possible, okay? And we try to often also get more help from other faculty. And thanks for coming here. In addition to our expertise, we also sought help from Dr. Juarez. Thanks for coming here, Dr. James Juarez. And everybody knows, I think, Dr. Barbara
Thorson,
Thorson.
Danish name.
Thank you for coming here. Okay. She also teaches project courses. And Dr. Hassan Badkabahi, okay, he's a professor in computer science, usually covers most of the mathematics courses, okay, mathematics. So calculus, right, and other mathematics. Thank you for coming. And Dr. Wine, Dr. Mudassar Wine, you may have taken courses with him, right? Okay, very good.
Very familiar.
Yeah. He's the program lead, manages the programs and I'll remember that.
No offense.
All right, so projects, MSCS projects usually comes after taking most of the courses, finishing other courses and so on, okay? And I think our program has some emphasis on software development, software engineering, aspects of software and aspects of database, so on, okay? So we don't have a hardware track in this program, okay? And most of us assume that when students start the program, they are more dependent on professors, so, okay? And toward the end, they become relatively independent. They can define a project independently, work independently, and in team. So team experience we try to give. Also, the student with minimal dependence, they can define a problem and solve it and give a presentation, okay? So, any questions before we start? Any suggestion? No. The format is pretty well known among those who are here. Format is basically student present for about 25-30 minutes and then leave some time for question answers and so on. But judges who are evaluating, they can ask question anytime, okay? They can interrupt and ask if it is very important. Otherwise, questions are for the end. It is informal. All right. So let's get started. The first project is object detection and tracking machine. Okay, and it is listed under team number 2 in the handout. Okay. So go ahead. Introduce yourself. And also, I want to tell you some drinks that are available. Some cold
Already
drinks.
started. Yeah, because he was speaking. He's also important.
Thank you so much.
So good afternoon, everyone. My name is Sangeeta Joshi, and my
team, and I will represent our project. So first of all, our project name is the Object Detection and Tracking the Machine by TechXllent. So TechXllent is our team name. We are the 5 member in a team, which includes myself, Pansidhar Mansani, Ron Welly, Rakshita Shakamure, and Jessica Susanto. So today's presentation, we divide in a 7 part, which includes introduction, system component, deployment architecture, implementation, user interface, and demo, where we show how our product works, test plan, and last it will be the conclusion. So about our project, so our main focus for our project was the detect the object and calculate the distance between the camera and the object, and also interaction between the Jackson TX1, Roberio, and FRC driver station. So let's talk about the computer vision. So computer vision has changed the technology world a lot. As a computer vision must interpret what it sees. So computer vision is enable computer to see, identify, and process the image same as the human vision does. Also, computer vision is closely linked with the artificial intelligence. So same as I said, the computer must interpret what it sees and to provide the appropriate output. Computer vision also provide very useful result based on what is observed. So as an example, so there is a semi-autonomous car available in the market, which has a computer vision built-in, which helps system to detect the object around the car. So and then provide the information to the system, and then system will act accordingly. So let's say the car is moving and all of a sudden some obstacle come on our way, and then the system will detect that and then act accordingly, and it will stop the car, which helps to prevent the accident and saves a lot of lives. So computer vision, there is a lots of library which helps computer vision. Among that, we use the OpenCV. So OpenCV is the open source library which has the C++, Python, Java interface, and also it supports the multiple platform which helps to easy to use. There is a 2500 plus optimized algorithm which helps to process the image, video, detect the object, and also machine learning and so on. So we did this project to help the team name is the NU Robotics team. This team is a high school, National University high school team, and this student is very passionate to pursue their career in STEAM. And STEAM is a stand for science, technology, engineer, arts, and mathematics field. So this team is Robotics team participate in a competition named as the FRC. So FRC is a stand for the first robotic competition, and this competition is for the high school student competition. And this held each year. In this competition, each high school student has to build a robot following the FRC rules. So Robotics teams will be participating in a 2019 competition. And in this competition, the student build the robot, and the robot has to detect the object and lift the object and put it in a destination place. So last year there was a project based on a Raspberry Pi, and they were able to detect the object and calculate the distance, but the process was very slower, and that could be the one obstacle in winning the competition for the Robotics team. So therefore, to take this project in a different level, we did this project with the device name is the Jackson TX1, which is the processor. And Jackson TX1 is a faster processor than the Raspberry Pi, which helps Robotics team to win the competition. So we did is that we detect the object. Also, we calculate the distance between the object and the interaction between Jackson TX1, Roberio, and the FRC driver station. So you can see here is that there is a multiple difference in between the Raspberry Pi and Jackson TX1. So we figured, so Jackson TX1 is a better processor than the Raspberry Pi. That's the reason we choose the Jackson TX1 over the Raspberry Pi. So that's our overview of our project, and my friend Vansi will explain the system component.
So in the system components, I'm going to explain like what are the hardware devices and software we have used in this project. So starting with Jetson TX1. Jetson TX1, we can say it is a supercomputer. It can deploy up to teraflop level supercomputing. So it can solve 1 trillion operations per second. And NVIDIA has added CUDA 8 architecture to this, which stands for Computer Unified Device Architecture, which helps the programmer to take massive advantage of parallel processing. As parallel processing is very important in deep learning, this device can compute way faster than any other PC. And also, because of its high performance, we are using this, and this is very power efficient, consumes 10 times less power than any PC, and also delivers 10 times more power. So this powerful machine runs on Ubuntu OS, and we have used Python and OpenCV for programming. We have used Python and OpenCV as it have pre-built libraries which helps in deep learning, and Python has less code compared to the other programming languages. It is simple, easy to debug and understand, and it's faster for the development. As artificial intelligence and deep learning requires heavy knowledge for the people, this Python has pre-built libraries which helps for the beginners to do their work in the deep learning, as it is easy to understand and debug. Coming to Rio, this is the most advanced version of Rio, and this is the brain of the robot. So this is the one which controls the robot movements in the field, taking inputs from the number of devices like joysticks. This is very small, faster, and more powerful. So this device runs on Linux operating system, and it also supports LabVIEW, Java, and C++. For this project, we are using Java, and WPL libraries has one of the features like it is highly simplified programming language which helps the people to understand the robotics in an easier way. So FRC driver station. FRC driver station is designed by NI LabVIEW, and this is the only software which supports the movement of the robot in the field. So the number of devices connected to the Alienware, which is sitting on the near the driver place, and the instructions which are provided from the input devices are sent to the robot via this. And it also has different types of operations like teleoperated, autonomous. Teleoperated is where the driver controls the robot with the joysticks and other input devices, and autonomous is where the robot runs in autonomous mode. So this is our customized dashboard which we have built using HTML, CSS, and Node.js. This gets the live stream from the camera mounted on the robo and the camera mounted on the Jetson, and we also get the telemetry data from there saying where the object is in the field, at what distance, and at what angle it is located in the field. We can also adjust the frames per second and the resolution of the screen to reduce the bandwidth if in case we are consuming it in a heavy way. So this is the high-level design of the whole project, and this is the object or the target what we are taking in consideration. And this is NVIDIA Jetson TX1. This is RoboRio, and the two cameras are mounted on each of them. And these are connected to the router via LAN wires, and all of this setup sits on robot here. And all these can be controlled from the Alienware here using the IP. And my friend will explain about the deployment architecture of the project. Thank you.
Good afternoon, professors and classmates. I'm Ronwei Li. I'm going to introduce the deployment architecture of our project. In this section, I'll use several UML diagrams to preview and visualize our project from multiple computer science perspectives. And the first one is a use case diagram. It is used to show the functionalities of the system and shows the relationships between use cases, actors, and the system. As you can see, there are two actors, the user and the robot. The first use case is the user boots up the system. After that, the robot will start to detect the object. After the object is identified, the robot will send a live stream and telemetry data simultaneously to the user interface. So in the competition, the user also can change the resolution size of the live stream. The last use case is user shuts down the system when the competition is over. So as you can see here, the first and the last use cases are relatively clear and simple. So our main task are the middle four use cases. I'll use the rest UML diagrams to illustrate those use cases. Next one, activity diagrams. It shows the flow of actions. We use the activity diagram with swim lanes so we can clearly say each actor executes how many actions. In the JSON TX1 executes the first 4 actions for detecting objects. Then TX1 will send the live stream and telemetry data right away to the user interface, which are the next 2 use cases. The last one will be a user clicks the button on the UI and change the resolution, then the new live stream will be sent to the user interface. Next diagram is sequence diagram. It shows how operations are carried out, and it also shows the interactions between different objects. As you can see in this diagram, there are 5 actors, and messages are transferred between those factors for these 3 use cases. This is the next sequence diagram for changing the resolution of the live stream. Message will send from driver station to rubber rail, then to JSON TX1, and the new live stream message will send back to the UI, so the user can see the new live stream. Next diagram is state machine diagram. It models the nature of our system, and it also shows the behavior through state transitions. This is from the idle state, then object will identified. This is the live stream, and the telemetry data will be shown on the user interface. The last diagram is for changing the resolution of the live stream. The first state will be the live stream keep running, then the resolution sent to the TX1, and TX1 changes the resolution of the stream, and the new stream will be shown on the user interface. So my teammate Rakshita will take over the next part.
Hello everyone. As it is clear that our main objective is to detect the object, calculate the distance, and calculate the angle of that object using JSON TX1, and send this live stream and the telemetry data to the robot. I am going to explain how this in detail, the implementation takes place with the hardware devices. So first, detecting the object. This situation is like the camera on Jetson will scan the field, and each frame is taken and it is converted to HSV values, where like we set up the upper and lower boundaries of the image, and we calculate the set values on the frame, and we get the object detection. After detecting the object, we remove all the disturbances around the object to get the image that is available, like it is shown here on the left of the slide, where the only object that is detected in the screen. After that, we define the counters around the object, and after detecting the object, we also try to calculate the distance and the angle. For calculating the distance and angle, we train the machine in such a way that the camera on the Jetson will take a picture of the image of known width and known distance, and this is sent to this is stored in the local, where JPEG in the form of JPEG, and this is used to calculate the focal length of the camera. So for each frame the camera is scanned, the focal length is calculated, and using the focal length we calculate the distance here. So the output screen will show up with all the output parameters with both the distance and the angle. So here the angle is calculated by using the Pythagoras theorem, and this after calculating the telemetry data like the distance and the angle, this data is sent to the Robodio and as well as the driver station. So this communication and the integration part will be explained by Jessica.
So yeah, after calculating the distance and angle, so we want to see how the system actually integrates with one another. So the telemetry data and the resolution change instruction will be sent from JSON TX1 to Roborio through the UDP server. And in the code for inside the JSON TX1 and the Roborio, we have implemented this setting. Also, the live video stream is another data that is sent by JSON TX1, and this will be passed through the HTTP server. what happens is the FRC dashboard will request a URL or uniform resource locator that will allocate the stream as a URL inside the CSS as the background of an allocated space. And we also did multi-threading for parallel processing. And this is implemented because we have to run 3 different things at the same time. So calculating the telemetry data and sending data through UDP and HTTP server, they have to be done simultaneously. So network tables play a role in a sense that, so when data is actually sent from Jetson TX1 to RoboRio, it has to be shown on driver station, and network tables actually take this data and absorb it and just show it on the driver station. There is no storage taking place here, just because it is passing the data for operational purposes. So for a communication between the Jetson TX1 and the driver station, there is supposed to be an instant communication for the stream. And for security actually will cause an overhead, and we do not want this overhead to cause a delay, especially in the competition. So we do not have this security implemented. However, we have thought about, actually we can use WPA2 encryption using the advanced encryption standard and actually increase the security of this connection. Another thing we implemented on this project is Agile methodology. We have followed the Project Management Institute Agile framework, and we actually research more, and we know that Agile methodology actually proves faster development rate, faster product delivery, and an increased success rate in software development than the traditional methodologies. Also, we conducted weekly sprints following the Scrum framework, and we involved Dr. Morris as our sponsor, and for the weekly sprints for our features. So it is proven that Agile methodology also increase communication between the stakeholders. And now I'm going to show the user interface and the demo. So going to this. Okay. Oops. Okay. So I want to show you first this Python code. So what happens here is where there is the calculation of the telemetry data, and also the sending and receiving UDP server data, also the HTTP server taking place in this code. So we actually create these 3 threads that are running, that first run separately, but then we join them together for the multi-threading. But we also want to show you another code, which is for the RoboRio. This is done in Java, and this is where the UDP server sending and receiving data actually takes place in the RoboRio. And also for the FRC dashboard, as we mentioned, it is a customized version. So we have actually modified this FRC dashboard using these 3 different files, and we have successfully completed this part. So for the demonstration, we are going to run from the Jetson TX1 from here. So okay, it's running, and now we want to see whether the camera, the live stream from the USB camera is also running. So we have seen that, and this is where the network tables come in. And now we want to make sure there is, okay, the robot is enabled here, and now we are going to run the main UI, and this is the IP connecting to the RoboRio from the Jetson TX1. And here we go. There is the FRC dashboard. Here is where the USB camera live stream comes in, and here is the TX1 camera. So you can see here the angle and the distance keeps moving as see that it is reflected here for the distance and angle at the same time. Also, yeah, we want to show that the resolution buttons are here, and we have put it in place. So we're going to close this, and Rashida will continue with the test plan.
Yeah, as you saw the successful demonstration of our project, for any successful project, we have to have a test plan in proper. So for our project, we have gone through many of the trial and error methods, and we came up with the test plan checklist where we concentrated more on functional and both non-functional testings. So we also followed PMI, which Jessica mentioned about the framework, and we used the framework to research more on our testing, and we conducted our testing in a linear scripting framework. So this test plan includes both functional and non-functional. This functional testing includes unit testing, integration, regression, and acceptance testing. In unit testing, we actually wrote small modules of functions that calculates the distance, angle, and as well as like sending the data. These functions are scripted and those are tested in the unit testing. And in the integration testing, what the functions we wrote and the functions and also the functions we use for sending and receiving the data are also integrated and then tested here. And in the regression testing, this is the most done testing in our project, because for any simple change or a single variable change in our project, we have to check the system working condition. So we perform regression testing, and the acceptance testing is in this testing we involved our sponsor Dr. Waters, and we make sure that we validate our product by the end of a sprint. So in agile methodology, for every sprint we contact Dr. Waters and we get the validations from him. This is all about functional testing, and we also considered non-functional testings where it is the performance, stress, and usability testing. So in performance testing, we concentrated on how the Judson is able to calculate the distance and calculate the angle, and also send this data to the Roborio and as well as the driver station. So this has to be done in no time. So in performance testing, we tested on all its performance based. So stress testing. Stress testing is that the system should work properly and as expected when there is like, if certain case is taken, like the use case, like if the ball is supposed to have in the frame and it is somewhere in small portion of it is available in the frame, even though the Judson has to detect the object and calculate all the telemetry data and send to the Roborio and the driver station. So here the stress testing is performed, and usability testing is that we deliver our system beforehand to Dr. Waters, like the handover report, where we can see our product working and how comfortable they are using it through the usability testing. So by tracking, like in order to have a proper plan, we came up with the test plan checklist where you can see some of the examples here. Like we concentrated on Judson scanning the image where we took it as a test cases number, and it maps to a requirements ID. Every test case we define, it maps to a requirement ID. So we make sure that there is a validation at what we perform. In order to explain it in detail about the test cases, like we involved linear structure framework. So we took, for example, it's here the object detection and calibration test case is taken, and we considered the preconditions and post conditions of that particular test case, and we check the results whether it is a pass or fail. So this is a sample test case that I am providing here, and actually the test cases are more important for any product that we are going to deliver in order to be successful. So my friend Jessica will conclude with all the future scope and also about the lessons learned which are important to us. Thank you.
So yeah, so I'm going to talk about the conclusion of this project. And first, we want to talk about the lessons learned through software and hardware. Even like the Jetson TX1, Roborio, FRC driver station, FRC dashboard, those are new things to us. But actually, there is more software that we try to learn, but at the same time, it doesn't help us, so we do not end up using it. Also, we learned for coding in Python and OpenCV. We learned the basics from Linda courses, but at the end of the day, we can implement the code that we have done from scratch. So also we learned about the integration between the several hardware, as I've already mentioned, about the UDP and HTTP server, and how we have actually learned how to actually run multi-thread for parallel processing. We also learned about the agile methodology, and we conducted the sprints. This actually prepared us for the future because of the workplace requirements. Also, there are some outcomes of this project that we have discussed about. So we have done the requirement analysis where we actually involved the sponsor to actually ask what is actually the requirements of this project, and we have fulfilled this. And we also, again, for the agile methodology, we have done it as it's supposed to be, following a framework that is already available. Also, as you can see, we have done the diagrams and test plan according to what we have learned and actually applied it in our project. Also, for the front-end application, this is especially true because we use this for the FRC dashboard and we customize it from the beginning. And also, at the end of the day, we have delivered a working product that satisfies the sponsor and probably the users. Yeah. And some future thoughts that we have, some future studies that we have thought about that are actually not in our scope is first running the robot actually in an autonomous mode. So what we thought about is right now the Jetson TX1 already sends telemetry data to Roborio. So why not have a robot that can actually use this telemetry data and move the robot autonomously? And then Jetson TX1 right now controls only one robot, and because this is a powerful processor, Jetson TX1 can be used for multiple robots. So also, Jetson TX1 is the only one detecting an object, but if the driver station can detect other robots in the field, it would prevent the robot to actually from colliding with other robots in the field. Other thoughts that we have is having a system that controls access to the robots. So we thought of having a user authentication system so we can limit who can use the robot build. And also, right now we are only targeting one object, which is the goal that you saw. And since TX1 again is a powerful processor, it can probably detect multiple objects based on shape, like rectangular or cubical or circular. And also we have thought about uploading images from robots to the cloud. This can be a source of database, but at the same time, that can be used for analysis purposes for the future. And we want to thank you for your attention. We also want to thank Dr. Day and Dr. Sinha for their help for this capstone. We also want to thank our professors who have been helping us throughout the program, especially those who have taught us, like Professor Jawad and Professor Warren as well. And we especially want to thank Dr. Wars for being a great sponsor and a great mentor for us, and have always been there for us. Thank you.
Thank you.
Questions, comments?
Okay. I would like to ask, what exactly is your contribution to this project? Like, you took different components, assembled them together. Programming was the main contribution. What is your contribution?
The main focus is to provide computer vision, like the vision for the robot. That is the main objective for us.
No. What is your contribution? What you guys did?
Yeah. We worked on the Jetson for the detection of the object, and we also integrated with the Roborio, which stays on the robot. As of now, they are using the robot for just moving purpose and lifting and physical activity. With the Jetson, we can identify the object and even tell the robot, like the brain of the robot, so to move the directions in which directions they have to head to.
So you mainly did programming,
Yeah.
right?
Yeah.
That's
It's a
yeah.
software.
Now, you mentioned in your presentation you use an agile method, right? Which other methods you looked at, and why did you select agile?
Okay, we have chosen waterfall method, but gathering the requirements, like all the requirements at a single time is not possible as the requirements keep on changing. At first, we don't know what actually the object is. It was revealed in the first week of February, but we have started our project in the month of December. So all the requirements gathered till the month of December and month of January was not sufficient enough to do this project. When the actual object came into the focus, we have to change our requirements. So the waterfall model which we used did actually work. So then we shifted to agile methodology, and also some of the requirements were changed by the professor, like who is our sponsor. So we have used agile methodology to change what if any new coming requirements or any changes we have to made in the past code or anything which is to be changed.
Good. Thank you.
Barbara,
I just wish to acknowledge how well prepared each of the presenters were with a wonderfully smooth description of what your involvement has been. And I had no trouble understanding it. It flowed forward throughout the whole presentation, so I'm really pleased. I'm glad to be pleased because I'll be teaching the same course in the summertime, so my expectations are really high right now. I do have a specific curiosity about Python and OpenCV as software development languages, and what you might have needed to take on for the learning of that during this capstone, or whether the learning that came forward from your past helped you out.
Like this was completely new to us, both the programming languages. We dealt with other programming languages in the previous courses for developing web applications. But when we started researching about how computer vision works and what we actually needed for the project, we came to know that OpenCV is an open source language which we can use for free of cost. And Python and OpenCV have already pre-built libraries which can say like what the object is, and we can simply use that libraries provided in them to remove the disturbances around the object, to find the object where it is in the frame, and calculating all distances and angles. So we just plug in our variables and other values and our thoughts into the pre-built libraries, and we got the solutions back.
Was it a skill that you needed to acquire quickly at the timing of the project? And just connect with that, is the language Python and OpenCV or the other open, like Linux and those, something that you might suggest be integrated with as new learning in the courses that lead up to the capstone or graduating or afterwards?
Yes, we definitely suggest them, as like these are the leading things, as the market is completely changing to Python now for everything like machine learning, artificial intelligence, and Python also uses very less code, and it's very easy to understand for the beginners. Like artificial intelligence and deep learning, they require like a lot of programming knowledge and experience, but Python will make it simple, in a simpler way understanding the things.
So
So we
it
would
was the
suggest it
simplicity of it, that, plus the compatibility with the gadgets.
Yes.
Yes.
Thank you, Dr. Dr. Amin.
Yeah, I don't have any question, but I like to just make some comment. Maybe I can ask one question to you guys that is very easy for you to answer. Like, did you get involved with the National University Academy school, like
Yes.
student who usually participate in the robotic contest?
Yes.
So did you mentor them?
Yes.
Okay. So my comment is that what James is doing, Dr. Boyers, he is actually killing two birds with one. Okay? And I really appreciate your contribution. Especially this project does not mean only in this room. It has a great contribution to our National University Academy high school students. Usually they go for the robotic contest. And I participated, I attended some of those. Really, really interesting. And I see what you have done, the accurate, detection and tracking of the ball when they try to put on the, basket or design it, place. That's very, very important. Okay? So looks like you have improved a lot, for their project. So there may be, hopefully, next time they will be even the better. I know last time,
Automation.
last time they have done excellent, The first one was little bit, immature, I know, I remember. Second time with the, it was great. Hopefully this time it will be much more very good. So anyway, thank you for, helping those kids also, the high school student, they are really, really, eager to learn something from you. Anyway, thank you, James, for your contribution.
Thank you, Dr. Amin. Any question, comment?
I would like to thank Mr. Group. They worked hard, hardware and software. Their presentation is awesome. So thank you so much.
Thank you. Yeah.
Well prepared, well presented, and very good cooperation. And it's very understandable.
Any other questions, comments? Yeah.
Yeah, is the ball stationary?
No.
It moves around?
Yeah, it moves around.
Okay. And the camera can pick up like a bouncing ball or?
Yeah.
Yes.
They showed here just distance little, but ball can, yeah.
Be in.
So since it's done repeatedly. Okay, well, special thanks to Dr. Juarez. Semi-autonomous, I want to just say, this is a very crucial phase of research in robotics. Semi-autonomous robot means the control is shared by human partly and partly with robotic systems. So the cars are becoming now autonomous. Tesla has autopilot mode, okay, and so on. But what is happening? Many of these experimental systems have problems. Because humans, if they are in full control, human can handle it, okay. But if the system is fully autonomous, then also human can leave it to it. But semi-autonomous means human has to share the control with the machine. Machine is taking autopilot, but when human intervention is needed, often mistakes are made. So some very famous, say, airplane disasters and so on happen, some accident, and some on the road also with some systems happen. So this is a good area to work on for this time, because job market is very good. Because a lot of experimentation has to be done in order to find out how exactly human fit into this shared control. Okay. So thanks for your attention. Any other comments? Okay, I want to tell you, setup time is about 2 minutes. So next presentation is Farzan. Farzan. All right?
Yeah.